Good day everyone. We are here to talk about the topic in real analysis, specifically convergent and divergent application to sequence and series. Now, in this topic, we are assuming that we already know the idea, or we already have an idea about convergent and divergent, and also about the concept of sequence and series. Now, let us take a look on the following example. This is a sequence. Given the sequence, the first term is 1, the next term is 2, the next term is 3, and so on. Now, we want to find out what the sequence does when the limit approach to infinity. If you take a look on this sequence, it is approaching to infinity, therefore the sequence is divergent. Now, take a look again on this example, n over n plus 1. Given this specific sequence, we are having the terms of 1/2, 2/3, 3/4, 4/5, and so on. Now, as we can see, this new sequence formed by this given sequence, the sequence is approaching to 1. Therefore, the limit is equals to 1. Thus, this sequence is convergent. There are sequences that are divergent without approaching to infinity. An example of this one is the sequence -1, 1, -1, 1, and so on. If you take a look on the graph, it is just an alternate -1 and 1 forever. So, the sequence is divergent. Now, if the sequence is asymptotically approaching to the limit or some limit, then the sequence is convergent. Otherwise, it is divergent. Now, we understand the concept of convergent and divergent for the sequences. Let us apply this concept to series. Series is when we add the terms in an infinite sequences. Now, if you take a look on this example, this sequence, this can be listed as 1, the second term is 2, 3, and so on. Now, this is an infinite sequence. When we talk about series, so we add the terms. We have 1 plus 2 plus 3 and so on. This is what we call infinite series. Now, this can be listed in this kind of notation. Summation of n from 1 to infinity. Thus, if we add up all the positive integers, then the sum of these terms will be infinity as well. Now, first, the first term. Second, we add the first two terms. Third, we add the first three terms, and so on. Then it will give us a new sequence having 1, the next term is 3, the next term is 6, 10, 15, and so on. If we will try to find out the limit of this new sequence, then as we can see, it is approaching to infinity, therefore it is divergent. Series is divergent. Let us look on this another example, summation of 1 over 2 raised to n from 1 to infinity. Given, the terms are 1/2 plus 1/4 plus 1/8 and so on. Now, the first term is a sub 1, then second is we add this first two terms, next we add the first three terms and so on. Then it will give us a new sequence, 1/2 plus 3/4 plus 7/8 and so on. This will be our new sequence. Now, if you take a look in this new sequence, it is approaching to 1. Thus, this infinite series is convergent. Now, as we can see, the summation of a sub n in the form of 1, 2, 3, 4 approaching to infinity, in order for a series to be convergent, its sequence must go to 0 in the limit of infinity. Thus, our limit here must be 0. The resulting series must be divergent. Now, a series may still be not convergent if its sequence goes to 0 in the limit of infinity. Now, a series is definitely divergent if its sequence does not converge to 0. Check out this following sequence. Summation of n squared over 5n squared plus 4 from 1 to infinity. If we take a look on this given sequence, it will result to 1, 9, 1, 6, 9 over 49, and so on. If we would like to find out the limit of this sequence, we simply divide first by n squared over n squared, and by simplification, it will result to 1/5. If the sequence does not converge to 0, then corresponding series must be convergent. That would be all. Thank you very much. God bless.